Hi everyone. I hope you guys are good and that you are well today. So we are back again with mathematics for grade 12. So we're just going to be starting a series on financial mathematics. So please just follow through all the videos that we'll be dropping, and just like our platform, follow the channel for more. So we're just going to be kicking off with the basics on financial maths. So this is the basics from grade 10 and also from grade 11. So as they are mentioning, that the revision exercise which follows is based on the work you did in financial mathematics for grade 11 and also other items that you have been introduced from grade 10. So I always say this, that before you actually tackle any mathematical question or anything related to math, just first understand the background, understand the theory behind, understand the concepts, so that by the time you tackle the questions, then you're familiar with the question, with the concepts. All right. So the first thing that you're supposed to know is the word simple interest. So simple interest has a formula of A equals to P bracket 1 plus I multiplied by N. Okay, so the A here represents the accumulated amount. So it means the amount that will be accumulated. So it's basically more or less like the amount of money that is still yet to be formed or calculated at the end. So that's the accumulated amount. That's A. P stands for the present value. So that's the amount that is present at that moment in time. So let's say this person is planning on taking a loan. So as this person is taking a loan, this person wants a loan of 50,000. That loan of 50,000, once it's granted to the person, it's a present amount the person wants. So that is your P. All right. And then that loan will have a certain interest rate, because all the banks and financial institutions, they add their own interest rate. So the interest rate is represented by I represents the interest rate. Okay, so we know the interest rate is always in terms of a percentage. So that percentage of an interest being added is added where? On the present amount, the amount that you have taken loan of. So if it's 50,000, they're going to add an interest rate probably of maybe 10.5 or 12 or 11, like. So that interest rate, it's the money that will be added on top of the initial amount that you have requested from the bank. So in total, the interest rate multiplied by the present amount, and then adding also the n. And here, guys, represents what? Represent your duration. So it's a period. So n can be what? N can be in the form of months, n can be months, n can be weeks, n can be days. So it depends. It can be days. So it can be semi-annual, semi-annual, meaning it happens twice a year. It can be quarterly, so it means, and then can be, yeah. So these are all right. So this what is a duration, the end, which can be in months, in weeks, in days, in semi-annual or quarter. All right. So that's your end. So you take that amount of money, 50,000 that the person has borrowed, you add the interest rate from the bank, and then you check that, okay, this person will be paying off this amount for the next 12 months or for the next 24 months. So once we take everything, put it in this formula, we get our what? We get our accumulated amount. It means this is the future money that the person will have to pay back to the bank, or this is the future money the person would have paid ultimately at the end to that institution that they have borrowed from. Okay, so that's A. A basically, the point is A is the future, P is the present, I is the interest, N represent your period. Okay, so the simple interest formula, guys, you must make sure that you have what? The interest rate is multiplied with the duration. That's the key thing to note for simple formula or simple interest formula. Okay, or sometimes this formula is called a straight line method. Okay, so you make sure that it's a, it's the interest rate multiplied by the period, and then this is how you basically see that this is the interest, simple interest, or a simple formula. Okay, or a straight line formula, I mean. Okay, then you have the compound interest. So this compound interest formula here, you basically have what, your a equals to P. Your A still here represents the future or the accumulated amount. P represents the present amount. It means the money that is present, the money that is needed, the money that is there at the present time. Okay, I represent the interest, to say this is the interest rate that will be added on that present amount that was maybe taken loan or something. And then the n here represents your duration, your period. So here, guys, to note, your n is raised to the power. N is raised to the power. For the simple interest, n is being multiplied. For the compound interest, n is being raised to a power. So very important for you to note that. And then same formula, we have the simple interest, we have the compound interest. We also have the depreciation for the very same things, guys. So the straight line method is our simple interest, remember. The reducing balance method is our compound interest. So we have the reducing balance depreciation. It means now there it's still the formula of the compound, but now we are talking of depreciation. For example, let's say a person had a car that was worth 100,000. That car, after 5 years, we want to know how much it will be worth. So it means the value of the car will be dropping. It will depreciate. Depreciate means now the value of that substance or the value of that material is dropping, is going down. So it means that after 10 years or after a certain number of years, that car will no longer cost us 100,000. It will be lesser than that 100,000 because it's used and it's breaking up and it's being fixed and stuff. So that because of that, it means the accumulated amount will be now lesser than your P. So that's depreciation. Whenever the P is greater than your A, that's depreciation. It means that what? It means your value of that material is depreciation is going down. Okay, so similar, we have for the simple interest, when the substance depreciate, we have minus, or we write it as minus. For the compound interest, when it depreciates, we write it as minus. For the appreciation, that means the value is going up, we denote those ones as plus, guys. For the depreciation, we denote those ones as minus. Very important for you to note that, okay? And then here, what they did is to actually make P to be subject to the formula. So if you make P here subject to the formula, you divide both sides by this part. You divide both sides by this part. The 1 plus I to the power of n. So when you divide both sides, then you get this formula here, right? So that's how they got you to this. And then we have another formula again, formula of IEFF. So the formula of IEFF says IEFF effective interest rate is equals to 1 plus I nominal interest rate divided by n, all raised to the power of n minus 1. So it is very important, guys, for you to know all these notations. So let's look at this notation. So there's a perfect picture that I love to actually use whenever explaining this. Okay, so just to go through what is the effective interest rate. So you let's say now you are given 10 sweets, right? You take those 10 sweets, or you give me those 10 sweets, let's say that, then within a year I will give you 11 sweets back to you. So that is the nominal interest rate. That speaks to a nominal interest rate, to say, okay, after a year, because of you'll be adding some of the sweets, you'll only add one sweet, so that's a 10%. That 10% interest rate is called a nominal interest rate. It means we take that debt, we don't factor in the compounding. We don't factor in the compounding interest rate. Whereas if the effective interest rate here, we say, okay, so now you have given me those 10 sweets, but because of you giving me those 10 sweets, every month I will give you a little bit of extra sweet. So because of the 10 sweets that you've given me, every month I'll give you a little bit of extra sweets. It means So for the effective interest rate, you add even more. So meaning that the interest rate is not only just looked at the end, but it is also factored in monthly to say the compounding interest. How is it affecting? So that compounding interest is being factored in. It is being added. All right. So you every month you will give a little bit of extra sweet because of now those 10 sweets, because this person was given 10 sweets. Those 10 sweets that this person was given, every month they are making extra sweets, extra small sweets. Those small sweets that are given or that are being made, they are also added up. So you'll find out that okay, after 12 months this person will have what, oh, I mean, this the amount or the number of sweets that will be found will be what, 11.6. That is the effective interest rate. It means now that we are looking here is that we the bank or we are factoring the magic of compound, the the effect that every suite will also generate its own interest rate, and ultimately it means the number of suites that you would have paid or that you would have will be far more than just looking at it with adding one suite. Okay, so hence why you get probably 11.6. So that means that 0.6, I mean that 1.6, it is an extra what? It is the interest rate that is being added here. Okay, so nominal interest rate and the effective interest rate, that is the main difference between the two. It means the first one, the nominal interest rate, you give a person those 10 sweets, and then in 1 year you will give back 11 sweets after 1 year end. That means you give back 11. It's one sweet being added here on the nominal interest rate. But on the effective interest rate, it is a different story now. Why? Because of now the very same number of sweets that you have given every month, it will give you a little bit of extra sweets for the effective interest rate. It means those sweets that were given, they will generate extra sweets every month, and those little sweets also make more sweets. So as a result, you get even more than one sweet that you get from the nominal interest rate. That this one is the effective interest rate. You are adding, you are factoring the compound interest. Whereas here, we don't necessarily factor the compound interest. We just look at it generally to say, okay, because of the interest rate, let's say it's 10%, that 10%, it will just add one sweet from what we had before. But here, that 10% is different, or that interest rate is different, because of here we're saying every month, as the sweets are there, each sweet will generate its own what? Its own little sweet, and then it will ultimately generate more sweets than what we had before. Okay, so that's the difference between the effective interest rate and the nominal interest rate. The main difference is that, guys, to say for the nominal interest rate, we just state the annual rate. This is say this is the annual rate, but the effective interest rate, we now check now the actual rate, but factoring the compounding interest. Okay, so that is the main difference between the two. This one has no compound being considered. This one, there is a compound being considered. Hence why even when you take a loan, it's not exactly that 10. If they say you're going to pay 10% interest, it's not exactly that 10% interest. It's probably also going to be more. It's because of these effective interest rate. Okay, all right, so and then let's continue. All right, so let's just jump straight into one of the questions. Let's have a look at one of the questions and see if we can be able to use these formulas that we just spoke about and just tackle one question. So they say here, Craig deposits 65,000 into a savings account, paying 15% per annum, compounded monthly. So guys, these key points are very important. They are telling you that it's compounded monthly, so it means that now the duration, the period will be monthly, it will be n. And we know for each year, how many months do we have? We have 12 months. All right. So it means for each year we have 12 months. Then they say he wants to buy a car in 3 years' time. So he wants to buy a car in 3 years' time, and then they say calculate how much money will be available for him in 3 years' time if he makes a further deposit of 10,000 into the account 1 year after his first deposit. So it means 1 year after his first deposit, there's an additional amount of 10,000 that is being made. So they want us to calculate how much money will be available for him in 3 years' time if he makes that further deposit. All right, so let's go to the writing board. Okay, let's go to the writing board. So we know what do we know now. We know that we are told that we have 65,000. That 65,000 is the present amount. It's there. So that 65,000 is P, is our P. We know that is P is the present amount. It's 65k. And how did I know that is P is the present amount? Reading the statement, they say Craig deposit 65,000. So that means he has already deposited that 65,000. It's a present, okay? And then you are told that it's 15% per annum. That's the interest rate. That's your I. All right. So we have the I as well. Our I is 15%. Our I is 15%. So we take that I remember we are not going to use it as a percentage. We're going to take that percentage divided by 100 for us to use it in a decimal form. So in a decimal form is going to be 0.15, and then from here we are told that our duration, guys, we said how many? It's 3 years, but that 3 years is compounded monthly. So that means our end here is monthly, which is for every month we have, for every year I mean, we have 12 months. So it's going to be like 12 months multiplied by our duration, because of we want our period to be months. So basically here what we are doing is we are converting the years into months. Okay, so 3 times 12 is going to be what? It's going to be 36. So we take that 36, it's going to be 36 months. Okay, and then yeah, let's calculate now that how much he would have paid after 3 years. Okay, so we want the A basically here, the accumulated amount. So because they use the word compounded, it means we are supposed to use the formula, the compound formula. So guys, these questions you will be given clues, so look out for clues like those component monthly and other things there. Those are your key clues. So the word compound there means we are supposed to use the compound formula. So it's going to be P 1 plus I to the power of n, right? Then our P is going to be 65,000. 1 plus our interest rate is going to be that 0.15. And then here's a key thing, guys: the interest rate that you have, always divide it with your n, with your period. So what was our period? Was 36. So that interest rate is over the period of 36 months. And then why? Because of, remember, the interest rate they said is 15% compounded monthly. So that's why we divide by 36. And then the duration is 36 months. So our duration is 36. We put everything in a calculator. Ultimately, you get what? You get your, if you punch everything, you get 101,656,10. All right. And then now, remember, guys, because of this person has added a 10,000, it means we also need to factor that amount that was added. So if we read again here, they said if he makes a further deposit of 10,000 into their account, so the deposit of 10,000 is made into the account, and that deposit of 10,000 also has its own interest rate, also has the compounding interest being involved in it. So you're also supposed to use the compound formula for that as well. All right, so we are also going to say, okay, we have our other A, our accumulated amount as well, which is 1 plus I to the power of n equals to, we take that, now our present amount is 10,000 that was used. We want to know that 10,000 after duration, the period, how much it will be. Okay, our interest rate we know still know our interest rate is what? 0.15. Our interest rate is still 0.15. Okay, then that 0.15 you divide it with your n, guys. You divide it with your n. Okay, so your n here, because of it's still 0.15, that's still compounded monthly, so we are supposed to divide that one with what? With 12. Okay, all right, then just a mistake, guys, just to correct this is divide by 12, not 36. Apologies on that. Here it's divided by 12. 0.15 is our interest rate. So since they said it's compounded monthly, it means that it's compounded per annum. I mean, it's 12% per annum compounded monthly. It means that interest rate is supposed to be divided by 12, guys. Okay, it's divided by 12. Okay. Uh, Okay, and then here, let's continue here. The duration here, guys, is because of we have n. So when we read here, they said, okay, if he makes a further deposit of 10,000 into one account 1 year after his first deposit. Okay, so it means after 1 year he made a deposit of 10,000. Now the question is, how long did 10,000 stay into his account? If the entire duration was 3 years and this deposit was made 1 year after, it means the 10,000 only stayed for 2 years. All right, so let me explain that. How did I get to 2 years? So remember, we have, if we can put this into our timeline so that it makes sense, we have T0 here, and then we have T1, this is the first year, we have T2, and then this is the last year. Okay, so the initial, so they said after 1 year, so meaning here, so after 1 year, so the person, that means it took the person a year, and then here he added 10,000, so the 10,000 was added there. Okay, so the 10,000 was added here. This is where the 10,000 was added. Now, after the addition of the 10,000 only stayed into the account for how long? So we can check the duration. So it's 1 and 2. It means this 10,000 was into the account for 2 years. So meaning here our duration will be 2. So it will be 2. Our n, I mean period, will be 2, and then that 2 years we're going to multiply it with 12 so that we convert it into months. Since our period is in months, our n. Okay, then yeah, we take this, put everything in a calculator, and then we get 13,473. So please verify these, guys. Just verify this. This is the final answers here. Okay, and then afterwards we still haven't answered the question. The question was, calculate how much money is available for him in 3 years. So it means after 3 years, how much money will be available then. They want us to tell they want us to calculate the total amount of money. So it means we are going to add these two. So we can say this was A1 for the first duration, this was A2. So we're going to say A1 plus A2, that will be our 101, the amount that we got before, 656,10, plus 13,473 and 73 with 50 cents. So we add this together, then we get what? We get our total amount there. All right, and then quickly let's do the following question. The following question says, Craig then buys a car for the amount saved after 3 years. So for the amount saved after 3 years, he buys a car. He drives the car for 4 years and then sells the car. Suppose that after 4 years of reducing balance depreciation, that is a key, guys. They are giving you the formula to say, here now, use the formula of reducing balance depreciation. Okay, the car is worth 1/4 of its original value. So it means now that the car will be a quarter. So a quarter is that is the amount divided by 4. So it means the original amount that we had, we are going to divide that one with 4. Then we're going to get the value of its depreciation. They say calculate the depreciation interest rate as a percentage. Okay. Okay. So the trick for this question. So now for this one, we are told, okay, firstly we are told that we're using the reducing balance depreciation, the reducing balance depreciation method. So that's the one of 1 minus I to the power of ns. So know these formulas, and if not, you will be given also the formula sheet. So just know which one is which. Okay, and then for here, our P is going to be what? Our P, we don't have P, so our P is unknown. But we are told here from the statement that suppose that after 4 years, the car is worth 1/4 of its original value. So it means the original amount that we had, which is our P, after certain number of years, we have what? We have accumulated amount being 1/4 of what we had initially. So it means under A is going to be 1 over P, 1 over 4P, and then here we have P, then we have 1 minus our interest rate. That's what we want. We need to calculate. And our duration, let's check our duration again. Our duration is after 4 years. So here we are not told that compounded monthly or compounded semi-annually or whatever. So it means we're still going to keep that 4 here. And then yeah, from here guys, we just divide both sides. So P cancel P when you divide both sides by P, divide by P, and then we are left with 1 over 4. We are left with 1 over 4 equals to 1 minus I to the power of 4. And here guys, you can put the fourth root. Remember the fourth root. Here you can put fourth root, what you do on the left, you do on the right, so that here we have 1 minus I, and then on the other side we have what? We have the fourth root of 1 over 4. You take then you take this one to the other side. Our I will be 1 minus the fourth root of 1 over 4. All right, then put all this in the calculator, you get 0.7071. Okay, let's write it this way, and then ultimately you take this multiplied by 100, then you get to see that your percentage will be, oh, okay, this is 1 minus, sorry, 1 minus, so put everything in the calculator, you get 0.29. So this is going to be your answer. Then you multiply this with 100, then you get what you get. Your percentage is 29. Okay, let's round it off so it's 29. That's a percentage, your interest rate. Okay, so yeah, just the key items to note, guys. Key items to note, or key things to note, is your N represent your period. So once they say component monthly, make sure that you are going to multiply that one with 12, and then for the interest rate you divide with the 12. If you multiply here with 12, here you divide with 12. If they said semi-annually, that means here you're going to say N, multiply that N, maybe it's 4 years or 5 years, multiply by 2, because they said it's semi-annual, it happens 2 times. The interest rate, and on this case, you are supposed to divide by 2. If they say quarterly, that means the N is multiplied by 4. The interest rate here is going to be I divided by that 4. So always take note of this, guys. To say the what you multiplied on the period, you're supposed to divide on the interest rate. That is very, very important to note. Okay, and then also depicting the right formula to use. That's very key. So the more you practice these questions, the more it's going to be easy for you to pick and to know which one is which. Okay, and then also don't make the mistake of swapping your A with your P. So read the statement carefully to know which one is A and which one is P. All right, so thank guys, just stay tuned for more videos. I hope this one was helpful. Please just like and comment. If you have any questions, just leave the question on the comment section, and then I'll get back to it. Thank you.